very fun tool to fuck around or to mess around with, and you can do a lot of different stuff. It's very, very good tool. Same thing with the bandsaw. You have the jigsaw. Basically, just a handheld version of the bandsaw. Pretty straightforward. Has a trigger for activating the blade. One good thing, actually in general for all tools, which I kind of glazed over, is that a good common rule to go by is that you should never be making contact between the material and the blade until the blade on any tool, whether handheld or stationary, is up to full RPM. The reason that is because if you do that before, you're going to get something close to what we were talking about with kickback or something like that, where the blade is actually going to try to dictate the path of the material rather than you having it in full rotation and cutting it. It's going to try to grab it and move it. So that's sort of the basic principle for that. Yeah, I think drills are pretty straightforward, but actually it's funny. I think the majority of people have never actually properly used a drill, which means that you actually use this in two different ways. You drill with it and you drive with it. So drilling is always going to be in your second mode here, which actually is relational to the speed or the RPM at which this is going to go. You also have your chuck adjustment here, which is also definitely related to the number that you're referencing. Most of the time, you never want to have the chuck activated into the number setting while it's in 2 mode, because what you're trying to do is drill. So you want it to go as fast as possible without any resistance. So at that point, you want to actually put it into the drill mode with that small drill indicator. And that's basically going to allow you, without any hesitation, or at least the best that the motor and the drill can keep up with you, it's just going to allow you to drill without any hesitation. Now, say we're driving a screw in, for instance, like here. When we put these in, we wanted the heads of those screws to seat in exactly the same distance or as relative to it as we could every single time across, 100 screws. And the way that you can do that is actually by adjusting the drill into the first mode, and that's going to slow down the RPM of the drill. So at that point, you also have a lot more ability to control the speed at which it moves. So I can literally just barely let that thing move, or I can pick it all the way up if I'm confident. But in the same motion, you never want to have your drill in drill mode while you're in 1. So that's where you want to start to play with your chuck. If I have it all the way down to 1, that means the slightest bit of pressure is going to engage the chuck, which is actually going to stop the motor from working anymore. And that's going to prevent you from overdriving a screw into your material. So that's definitely something that I always suggest to people is when you're working through systems, always use scrap to test out ideas, right? So if you know the very particularities of your material that you're about to lock into, and you have a very particular sort of aesthetic in mind where you want the screw to sit in a certain way within the material, yeah, I would basically take a row of holes that you punch and basically start driving in screws and start slightly adjusting to and from your numbers until you reach that sweet point that gives you exactly what you want. And there's not a shortcut to that, it's just trial and error. But yeah, that's the basic idea of that. And that's called, and actually that's what's funny, a lot of people, I actually just learned this. This particular one is called a drill driver. And that's back to that basic idea that it does both drilling and driving. Then there's the impact driver. So this is not for drilling. This is just for driving the screws. Now, this is the complete opposite of the drill driver, where we have a lot of sort of like, you have a lot of sort of control over the particularities that you want to achieve in that. This is not made for that. This is like when you're constructing a deck or putting a framing in, you're not worried about how the particularities of its seating, you just need it to be in there as quick as possible in repetition. So that's what this drill is awesome for. It basically has a really strong ratcheting system in it, to where basically once you start to drive a screw, the first time that it senses resistance, it turns off the motor and basically kicks it back into high mode. So that basically you're getting like a pulse action that basically helps drive the screw in as it's rotating in. Super loud, but will give you little to no resistance, and especially when you're doing construction stuff, in terms of like framing and stuff of that nature, you'll get something that's called jacking, which probably most people have had before, where you try to, yeah, screws can be hot when you take them out. But basically when you're trying to screw two pieces of wood together, and for some reason, just before it happens, the two pieces of wood want to spread apart from one another. It's called jacking. And that's all within the design of the screw in relation to the tool that you're using, but with an impact driver that basically takes that out of the rotation, because it basically, in that pulsing action, is basically taking that resistance out of it and just pushing it through, kind of manhandling it into position. But this is an awesome tool, especially for speed and power. But definitely not meant to like take apart your TV remote. Home standards, I'm really not going to waste much time on it. There's really little damage that you can do to yourself other than literally taking it and applying it to yourself, which of course will hurt, but I think is pretty straightforward for most people. There's an on-off switch. There's a slight speed adjustment, actually, which, you know, depending on certain things that you're trying to get at, can definitely lead you in different directions. Obviously, 1 is going to be the least aggressive, all the way up to 6, which is the most aggressive. So in most cases, I put it into 6 because most of what I'm doing is trying to wear down materials to a particular point. But yeah, there's lots of sort of moments where maybe you enjoy the texture that the sandpaper leaves, or all kinds of things in between. But again, there's some malleability for people to test depending on what their process is. Yeah, brad nailers. We have 2 different versions. We have a 16 gauge and an 18 gauge. For whatever reason, they actually swap what you would intuitively think. So you would think 18 gauge is bigger than 16, but it is not. The lower the number in gauge means the thicker the material is, or the thicker the brads are in this case. So yeah, just as you are reading, this 18 gauge nailer is much smaller. Basically, you can load up a decent amount, sort of like a clip of nails, and basically has a quick release, which is just a small spring loaded button here that you press. That basically allows for the chamber to open. Surprisingly, a lot of people can mess this up. If you look at the brads, you can kind of clearly see a defined head in the body of the screw, or brad, sorry. And basically if you can kind of imagine the path in which the nail is going to shoot, you basically want the tip of the brad to be pointed towards the tip of the gun. That's basically it. It has a pneumatic connection, which basically hooks up to an air hose, and at that point, it's on a stagnant pressure, which reads accurate for this. The only thing that at that point you can really adjust is basically on the top here. There's a left to right adjustment, which basically adds an increased depth or decreased depth of the plunge rate at which the nail is going to go. So say you're working a really thin material and for some reason the pressure is so high that it's blasting through that first layer, you can actually adjust back to where the head of the brad will just barely seep into the material and be that perfect fit. So there's definitely some malleability there. Oh yeah, and this has a range of 5/8 of an inch in length of your brads up to 2 inches. So that's a big variety. So the palm router is, yeah, really very helpful tool, but also a very dangerous tool. It can definitely, it's probably one of the more versatile things. As you can see, we have like a large variety of router bits here, which can do all different kinds of things, from just dressing an edge to actually making cuts to just doing little ornamental details across your work, whatever it is. But you can definitely have a ton of different options in terms of how you dictate where the blade is running. This is called a bottom bearing router bit, which means that there's literally a bearing here that you can ride up against the edge of the material, in this straight shaft, or straight shoot, I think is what they call it, of the blade will basically, or the flute of the blade, will basically run right along this parallel edge wherever that is making contact with. So that's along a curve, along a straight edge, whatever it is, it'll follow exactly to that, which means that you can use this to make replicants from a template, variety of things. And the basic concept of that is always double check that your bit is locked in place, which basically happens here. I'll go one thing at a time. So you can have height adjustment, which is basically controlled by this mechanism, where once it's unlocked, you can either hand adjust it. You can also use this fine adjustment into lock it again. Then to actually adjust, well, not adjust, actually to remove the blade and basically replace it with others, you can see a small hole here. And this red button is basically attached to a pin that once you engage the hole properly will go into the hole and restrict the rotation. And then basically there's a giant nut here that locks down a chuck onto the blade. So at that point you can actually loosen the chuck, take your blade out and replace it, retighten. Now there is one of the more dangerous things about this particular tool is when people don't know, again, most of it is about knowing the directional nature of the blade in relation to the direction that you're moving the material or you're moving the machine. So this one actually has a rotation that works clockwise, kind of always going to your right. So actually what you want to do is follow suit with that rotation and move left to right with the rotation of the blade. Or I'm sorry, actually I believe I was wrong. I think it goes counterclockwise, and you actually want to be moving in opposition to the rotation of the blade. Just like with the table saw rotation, the blade is moving towards you, and you push the material against the blade that way. And then I think for the most part,